Okay, this is Unit 1, Lesson 8. We are in Chapter 9, Section 2. We're going to be talking about some stuff with parabolas in this lesson. Our content standards for this lesson are that we are going to interpret complicated expressions by viewing one or more of their parts as a single entity, and we're going to create equations in two or more variables to represent relationships between quantities and graph equations on coordinate axes with labels and scales. And the mathematical practice we are going to be focusing on is making sense of problems and persevering in solving them. So we've already learned how to graph quadratic functions. What we're going to do in this lesson is we're going to write equations of parabolas in standard form, and we're going to be graphing parabolas. Here's some new vocabulary terms. Okay, so the previous slide had some new terms. The biggest ones, the most important ones probably are the focus and the directrix. The focus and the directrix are just different ways of finding the equation of a parabola, and they help you to graph a parabola, a quadratic equation, by looking at different features of the function from vertex form. This is vertex form up here. So the equation for finding the location of the focus, and I know you don't know what a focus is or what a directrix is right now, but these are just the formulas for finding them. So if you need the formula later in the video, come back to about the 1 minute and 45-second mark in this video. All right, so our first example, we're going to be analyzing the equation of a parabola in this example. We have the equation negative x squared minus 2x plus 3, and it's in standard, we need to write it in standard form. We're going to identify the vertex, the axis of symmetry, and the direction of opening of the parabola. And this should pretty much be review for most of us. We're going to take this equation. So actually, if we look at this, it says we need to write it in standard form, but I'm pretty sure just by looking at this that it already is in standard form. Remember, standard form was ax squared plus bx plus c, and it's already written that way. So really all we need to do is identify the vertex and the axis of symmetry in the direction that the parabola opens. So the first thing I'm going to look at is if I need to find the vertex. When we're in standard form, the easiest way to do that is to do negative b over 2a, comma, and then take that point, negative b over 2a, and plug it in the function. So f of negative b over 2a. Make this first parentheses a little bit longer. Okay, so we can see here that a is negative 1, b is negative 2. So negative b would be the opposite of b. That would be positive 2. So we would have 2 over 2a. 2 times negative 1 is negative 2. And so 2 over negative 2, comma, 2 over negative 2 is really just negative 1. So f of negative 1, I'm just going to simplify it over here. So it's negative 1, comma, f of negative 1. So my point, negative 1, comma, this is a pretty crappy parentheses over here. Let me make it curved. I'm going to plug in negative 1. So right here, if I plug in negative 1 squared is positive 1. But then I have this negative, so I'm at negative 1. Negative 2 times negative 1, that's positive 2. And then plus 3. Negative 1 plus 2 is 1. Plus 3 is 4. So my vertex is negative 1 comma 4. My axis of symmetry would be x equals negative 1. And the direction that it opens, since a is negative, it opens down, which means that the parabola, if we were going to graph it, would look something like this. And hopefully it would look a lot prettier when you graphed it, but it's hard to write on here. So over here, what they did for their thing is they put the equation first in vertex form. And so that gives them the vertex right here, -1, 4, the same way we had our answer. The axis of symmetry, x is -1, and the parabola opens downward. All right, here's one for you guys to check your work on. See if you can do this. Oh, I see what they're doing here. They're calling standard form what we've been calling vertex form. I have no idea why they're doing that, and I've never seen that before. But basically what you need to do is take this from standard form and put it in vertex form. So they're looking for the equation in vertex form. So work on that, pause the video as long as you need. When you have your answer, come back and advance to the next slide. So the vertex form for this problem is C. Okay, example 2, we're going to graph the equation y equals 2x squared. So we can think about this starting off with finding the vertex. The vertex, if you think about this as standard form, would be -b/2a, but notice there isn't up here. There is no b value, there's no c value, there's only an a value. So if you did -b/2a, you'd have 0 divided by 2 times 2, which is just going to be 0. And then if you plugged 0 back in here, 2 times 0 squared, you're just going to get 0. So our vertex is just the origin, 0, 0. And then we're going to make a table on each side. Notice how they're not doing the values on the other side of 0. They're not doing -1, -2, -3, because we need to remember that the graph is already symmetric. And so if we get 1, 2, the symmetry would tell us that we also would have -1, 2. And if we have 2, 8, the symmetry would tell us we also have -2, 8, and so forth. So here is the graph of those points. Let me just put some dots on here in a different color. Here is our origin, 0, 0, that's our vertex. Then we had the point over 1 up to 1, 2. And we also had -1, 2. And we had 2, 8 is all the way up here. -2, 8 is over here. And we can't fit 318 and -318 on there, but just realize that they are in fact there. And here is our axis of symmetry, right down through the y-axis. Since x equals 0, there's our axis of symmetry, and notice how there's symmetry on each side. This is 1 space to the left, 1 space to the right. 2 spaces left, 2 spaces right. In part B of example 2, we're going to be graphing y equals 2 times the quantity x minus 1 squared minus 5. So notice that this equation is already in vertex form, so we should be able to see right away that our vertex is 1, -5. It says the graph of this equation is the graph of 2x squared. That was from part A. Notice because a is still 2. So this original graph, it's the same graph, but it's now shifted right 1 space because h was 1. The vertex is at 1, and it shifted 5 down since the vertex is at 1, -5. So the exact same graph that we did in part A is going to be here for this problem, but it's got a different vertex. So let me put some points on here. First, I'm going to do in green the location of the original vertex was at 0, 0. And notice how if I track this down, I go one space to the right and 5 down, 1, 2, 3, 4, 5, I now have my new vertex at this point, 1, -5. And the same thing happens for every single point from that previous problem. You might remember that we also had the point 1, 2, which was right here. And if I take that one and I track down, or I track over 1, down 1, 2, 3, 4, 5, notice how I touched right on my graph again, right here. Oops, didn't change colors. Right here. And notice again, these 2 pink points, this is the vertex. I went over 1, up 2, the same way from my original one, I went over 1, up 2. So you can see it's the exact same graph, it's just been shifted over 1 space to the right and down 5 spaces. Okay, for check your progress, figure out which one of these is the graph of -3x squared. When you have your answer, go on to the next slide. And our answer this time is B. Okay, so for part B, now we're going to find the graph of -3 times x plus 1 squared plus 3. And realize it's going to be the exact same graph as part A, it's going to have a different vertex. So figure out where the vertex is and then figure out which graph would be the correct graph for this one. When you have your answer, go on to the next slide. And our answer this time is A. You should have recognized from this that the vertex is -1, 3. So we would shift from the origin, we would go left 1 and up 3. There's our vertex, and that's the only one that has a vertex at that location. All right, we're going to pick up with example 3 in the next video.